All right, we're talking about inscribed angles in a circle. Let's review. We talked about a central angle in another video where the angle actually has a vertex that is in the center of the circle. So it subtends to the arc that is part of the edge of the circle. So your central angle's measure is equal to its arc. Now, in contrast, the inscribed angle has a vertex that touches the edge of the circle. So the vertex is the part where the two sides of the angle come together and meet. So subtend means that that angle is connected to an arc. So the measures of those angles will be different, but the arc measure will be the same. So for instance, if I know that the arc is 50 degrees, well, if I recall central angle, that means that my central angle is also 50 degrees. But what you're about to learn now is for inscribed angle, the formula is the measure of the angle is actually 1/2 of the arc. So instead of being 50 degrees, I would have to take half of that arc, which is 50, and half means to divide it by 2, and that will be the measure of my inscribed angle. So therefore, my inscribed angle will be 25 degrees. That's how that works. Sometimes the problems are a little bit more complicated. So let's get into situations where that might exist. In this instance, we're trying to find the measure of W, angle W. However, in order to use this formula, we would also need to know its arc that's subtended to it. So what do I mean by that? So again, the angle actually has its vertex on the edge of the circle, and the endpoints on the circle on the opposite side where the arc is created, that means it's subtended, it's connected to. So I'm only looking at that information when I'm trying to use this formula. I can't look at any other information. But I don't have enough information right now. I have the measure of angle W with the question mark, and I don't have anything given for the arc X, Y. So if that happens, I have to use what I do know. And what I do know is that an angle, the measure of an entire circle is 360 degrees. I'm given parts of the circle. I'm given two arcs. So what I can do then is take that information and set up an equation. 133 plus 161. And I would like to know the arc measure of x, y. And since I know if I connected all of that together, it would equal the entire circle, the measure of a circle is 360 degrees. So now what I would do is just simplify and solve for that arc. On this side, if I combine like terms, I end up with 294 plus arc x, y, or you can just name it x if that's what you want to call it. And now I just simplify even further by moving the 294 over to the other side, which means I have to take the inverse. And what I do to one side, I have to do to the other. Arc xy will end up being 66 degrees, but that's not what we're looking for. We're looking for the measure of the angle W. So in doing that, we're going to go to the formula that I just told you about, and we're looking for the measure of angle W. What we know is that it's 1/2 of the arc. Well, the arc we just found out was 66 degrees. So whenever you have the variable on the left-hand side by itself, you can just automatically simplify what's on the right-hand side. You don't have to do anything else. So 1/2 of 66 is the same as 66 divided by 2, which is 33 degrees. Remember, angles and arcs are measured in degrees. So that's it. You just found your inscribed angle. This next problem has an inscribed angle already given, but then they want you to find one of the other ones. There's multiple ways to do it. Since you have a triangle, you can try to figure it out knowing that the measure of a triangle equals 100. If you add all the angles together, they equal 180, but we're going to do it a different way. We're going to stick with that formula that I just showed you. So we already know that the measure of angle, and we're going to use M, is going to equal 1/2 of its arc. Well, we don't know the measure of that arc, right? Let me be more specific. So the arc that is subtended with the measure of, let me just show you. So this is my inscribed angle, and the arc that is subtended to it. So this is the endpoint L and the endpoint N. It creates an arc. So that's the arc that we're looking for. And that's what we're going to put here, LN. And we have enough information to find that arc, and then we can work and just keep working until we can find the other angle that we're actually looking for. So what you want to do is substitute what you know, and what you know is that the measure of angle M is 47 degrees, and it is equal to 1/2 of arc LN. If you ever see a number on on the left-hand side of the equation, you will be multiplying by 2. Why? Because you're trying to get rid of this fraction. And that fraction's denominator is 2. It's always going to be 1/2. So you would multiply both sides by 2. Really, it's 2/1 because it's the reciprocal of that fraction. But since 1 is the numerator, we'll just say 2. Okay, and then what you would do is focus more on the left-hand side, because this side, the whole purpose of doing that is because when you do an inverse, you're undoing something. So you wanted to get rid of that fraction. That was the entire reason that you multiply by 2. So when you multiply this side, 47 times 2, you end up with 94. And that's the measure of your arc, LN. So if you wanted to, you could just go ahead and write that over here. So if you're visual, you can see that. But again, we're trying to find the measure of angle N. Now, what we know is what we just did in example 1. We know the arc measures for 2 of those arcs. So now if we can find arc LM, we can work backwards and find the measure of angle N. So let's do that. All right, so what I want to do is set up an equation using what I know about the arcs, 94 plus 146 plus, I'm trying to find arc LM, and I know that's the entire circle, which measures 360 degrees. Combine my like terms, I have 240 plus arc LM. Again, it's equal to 360. And now I just subtract 240 on both sides, because what I do to one side, I have to do to the other to balance my equation. And that leaves me with the arc measure of LM is 120. Well, I wasn't looking for that. I'm looking for an angle, but again, I'll just go ahead and label my work. So I know that the arc that subtends the angle that I am looking for is 120. If I go back to my formula that will never change when I am referring to inscribed angles and just substitute what I know, I will be okay. So what do I know? Well, I don't know the measure of the angle. So that's what I'm trying to find, the measure of angle N this time. Why am I writing so crooked? Okay, it's going to equal 1/2 of, and now if I look, what arc subtends measure of angle N? It's arc LM. So now I substitute what I know. I don't know this measure of the angle. I do know, because I just found it, that arc LM equals 120 degrees. And now when I simplify, the measure of angle N is equal to 120 divided by 2, which is 60 degrees. So that's one way that you could find that find the measure of that inscribed angle. So you're finished. Keep up with your variables and your arcs and angles, or you will get confused. And then lastly, let's throw an expression in here. And again, we're dealing with inscribed angles, so we still want to use that formula. M, the measure of the angle is equal to 1/2 of the arc. That formula is not going anywhere. It's not changing. So just substitute what you know. Well, what's the measure of the angle? Well, first let's figure out what we're dealing with, because we have 3 inscribed angles. We're talking about the ones that have given information. So this is the only portion, and it looks like an ice cream cone. That's the only portion that we're working with. So we're going to use that information. We know that the measure of this angle is 56 degrees. And we know that it's 1/2 of its arc. Well, what is the arc? Well, this time the arc is an expression, 18x plus 4. I told you a few minutes ago, if you ever see a number on this side, you will automatically multiply by 2. And that's because you're trying to get rid of this fraction. And to get rid of that fraction, you want to multiply times the reciprocal. And the reciprocal, it is going to be, in this case, the denominator 2. So it's 2 over 1, really. But again, I don't want to put that over 1 to confuse somebody. So the whole purpose, what I do to one side, I do to the other, is to get rid of that 1/2. So 56 times 2 is going to result in 112. And when I get rid of that fraction, all I do is simply bring down what was in the parentheses. And now it should look familiar. I'm just going to go ahead and solve for x by subtracting 4 on both sides, which will end up with 112 minus 4, which is 108, equals 18x. Divide both sides by this 18 because that's what's stopping x from being by itself. And I'm just going to rewrite it with the x on the left-hand side. You don't have to. 108 divided by 18 is 6, but that's x. So if that's what I was looking for, then I'm finished. Let's just say that's what we were looking for in one case. So if I wanted to just check my answer to make sure, well, is this right? What I could do is I could use what I know. I could take that 18. I'm looking at this. So I can take the 18, replace the x with the 6 that I just came up with, plus 4. And now that will result in 112 because 18 times 6 is 102, 108. 108 plus 4 is 112. Well, now let's go back to our formula and let's see if that's actually true. Well, we already know that we can actually just, So we already know that the angle measure is 56, and we were told that it should be 1/2 of the arc. So the arc is 112. If we are doing the math here, 112 divided by 2 does result in 56. So yes, we did it correctly. So there are multiple ways that you will see your problem set up. Go back to your go-to formula, and you won't go wrong. Just always go back to that formula. If you haven't already, please subscribe and like the video. Have a great day.